Hey everyone, my name is Theophilus and I'll be taking you on the beginner's training for on Protastructure. Yes, so this is a free training brought to you by Gemma Metist. So I'll be taking on Protastructures, the beginning, the basic aspect of it. Let me start by telling you what Protastructure is about. Protastructure is structural analysis and design software that's step forward with its innovative BIM software. That's building information modeling for structural engineers to model, analyze, and design buildings in good time and accurately. So with good time and you accurately design your software, your buildings quickly. So it provides a sophisticated and flexible structural design engine, allowing you to optimize your entire building from the roof down to the foundation. Everything will be designed on data structure on a particular software. So it's the interactive software where you can interact with what you're designing. So um, well about that, I'll be taking on the beginner stage of Prota structure, and it's basically for structural engineers. So yeah, the outline I'll be using for this is the quick start guide, which comes with every software, Prota structure software that you have. When opening it, it will always bring up a pop-up that shows you an option to open the quick start guide. So I'll be taking you on three phases of this lecture. I'm breaking everything down to three parts, which is the starting part, the starting how to start a new project. That's to start a new project from files and everything, down to placing your access. I'll be using the quick start guide as a guide also because with that you can get the basics basically. That's the basics itself. So from starting a new project down to placing your axis, that will be the first phase of my lecture. Then from placing your axis to doing a project through and then running an analysis. You'll be doing a simple project here and down to running analysis. So that will be the second phase of this lecture. And the third phase will be from your analysis to getting all your reports, all your quantities and everything. So those are the three phases of this lecture. So let's get to it. This is um I want to open the quick start guide. So this is the quick start guide. This is what we're working with. This is on every software. Well, I'm using Protastructure 2021. So this is what we are working with. And I'm also using the software here. So we'll start first by opening a new project. So I'll be taking you on how to start a new project. This is the interface you first see when you open your Protastructure. So this is the first thing you're seeing. So how do you open a new project? This is the option. Open project. This one is to open a previous project that you have there already. Then this is to open a new project. Okay. This is the start page. Um, this is to open existing projects. This is to start a new project. This is Prota News to read Prota News and watch videos on Protastructure. I think these are also like tutorial videos on Protastructure. Then there's also a bar to read more information on other things. So this starting a new project. We'll click on Open Project in the Start page. So this is the Open Project dialog. These are my previous projects. So the first um this is a folder obviously for it's safe to where your projects are being stored. Then this area, this is the place where the data folder. This is by default a data folder called Prota 2021 will be installed in document. So this is the data folder. This is the document where all your data will be that is created already automatically. So all your files will be saved into it. Then if required, you can specify a different location by clicking choose to create folder. So you can change the location of where you want your software or design to be saved. So explore will open the current project data folder. So you can open it and view the files there. Then you can open existing projects stored in this data folder through this. These are existing projects. So if I click on any of this now, I will be opening an existing project that I've already done. Then JSR basics, this is drop down list. Then this your most recent use projects. This is a most recently used projects to quickly show you the list of recent projects opened. Basically, these are my recent projects, so I don't need to be clicking on this. I just go to all projects. So let's go straight to the tip. Previous versions models can be opened directly on Protastructure 2021 or other Protastructure. All you need to do is firstly, you choose the correct data folder by clicking choose to create folder. That's this. Then browse the desired data folder. Then you will be able to see the project and open it. You will be prompted to won't save the model as another name after converting the project to open. Then the newer projects can be open in older versions. That's one. Then these newer projects can be open on former versions, but the previous versions, the projects you've done on previous versions can be opened on the newer versions. So I'll be starting a new project. So we'll click on new project. So let's close this. Let's click on new project. So yeah, we'll tap on. I'm following the quick start guides. So we'll be tapping on Singapore Euro code. But here in Nigeria, though we use UK BS 8110 for our structural designs. But since we are following the quick start guide, we'll go with this. So these templates now, these are the already given templates we are prepared for us. But then if you have templates from other projects that want to copy and use, that's when you go use projects. So you can click on any of these projects and of your projects, and then the templates you used there on those projects will automatically be used for this. What we are using in new templates, we don't use a previous project templates from previous projects, so we are choosing BS 8110 and then click OK. Okay. Oh yes. I forgot one thing, the name. So I'll be naming this. Uh, Let me just name it beginners. Beginner. I'm sorry. Here we can't use spacebar, so what you use is the underscore. Let me say beginner learning. Okay, and then click OK. So it will load. So this is our main modeling area. So this is what we have for our main modeling area. So with this now, the grid lines, you will see they are smaller grids inside, smaller boxes. They are 1 meter by 1 meter by default. And then this larger area, the major grid colored by darker gray. And you can see it's thick and darker. It's 5 meter by 5 meter. And this can be changed by our default setting button. But it's all in the our design setting, display setting. So this is the display setting, so you can change it there. But we'll get to that aspect. So now let's get used to our user interface. So first, this is the file. Our file with new project, open project and the rest. So this is what concerns with the file. Then these are quick access. The quick access is a place where you can easily access tools, and things can be added to other things can be added to your quick access. Like you can just right click on any command and you see the option to add to quick access toolbar. So immediately click on add to quick access toolbar. It will be appear here. So it will be one of the tools there for you to easily use. Then we have our tab toolbar. That's this the building setup, the modeling, loading, review, analysis, design drawings, and reports. BIM, display, views, help. So that's our tab toolbar. We can just follow what I'm saying on the quick start guide. Then we have our zoom options. Refresh, rotate, zoom. That's this area. Then we have our structural tree here. The more we design, you see the structural tree begin to grow from the axis down to other areas. Then the views. We have different views. We have the plan view, 3D physical model, the 3D river model, the analytical model. That's what this version of Protastructure provides for us. Then we have our commands for the selected tab toolbar. So with each tab toolbar, you have different commands. So while clicking on you expose the other commands within them. So these are the commands under each of them. So um what else? We have our status bar here at the bottom. Our status bar is at the bottom. Then our command entry. This is the command entry. Then our units. Then the cursor coordinates. So that's our interface. So for let's get to it one by one. So let's start from building setouts toolbar. So you can see this is the group. This is divided in the quick start guide, the group, the command, the tooltip. So when you just hover around um a command, it will show you the tip of its usage and everything to tip the usage and what it is. So clicking on this gives the commands, makes each command active in your design. And they are grouped into different assets. This is group of files, groups. So moving on, then the views. When you go to views, you can see the different views. Plan, 3D river, analytical model. This comes up after you've designed. Then you can tile horizontal, tile vertical, smart tile. That like you have different, like let me see 3 to 4 different views open at once. Like the be tile arranged on the screen altogether. So you can see that there. Then the structural tree, we've not yet started, so you see as it grows. Then quick access toolbar. I've showed you how to add you can add this command, any command to a quick access toolbar by right clicking and clicking on the add tool. So let's go to the display setting. This is the display setting. These are the display setting. So we have colors. You can change the background style, the color, any of the colors you want to change, the axis indicator color, they're all here. Then your grid. I told you by default we have five major lines, and that's every we have major lines at every 5 meter. So and the grid step is 1 meter, that's 1000 millimeter. So the color also is here. You can change the color. Then automatic grid in new views, it's on, so you can change those settings. So you can see all those settings on the by following the quick start guides. Then active Windows setting and visual interrogation. The visual setting. This is for our background display, object mode and what else. So let me close this. The layer setting. Let me open the settings center. This all the settings are all here. They are all here. So we're going to what is your interface? These are the settings and everything. So let's start with something interesting. So the settings center. Quick start. So this is the settings center. I will open it before. Just open it again. So we'll change our settings for this view and save. So we have the settings already automatically save interval. So we have to change it according to the quick start guide. By default it's 0, meaning it's disabled, but I have already changed mine to 10 minutes. So you change your on also to 10 minutes. So it will automatically save at 10 minutes. Then you untick this prompt for automatic saving. What it means is that it will be if it's clicked now before it saves it will show you that I'm about to save it. It will interrupt your work. It will ask for permission to save okay or not to save. So instead of that, you can allow it to save automatically. So by unclicking this, I mean, you are it's automatically save without interrupting. It will save in the background. So um let's go down to your project template. Okay, yes, this is showing that I've not saved anything yet. Template manager. You can change your template here. You can run any edits you want to run. You have your templates here. You can import. You want to select one. So Malaysia 8110. Just using what you say here. Then select all to tick all of this. Then import. Is to import all the templates for select settings group to this. Do you want to continue? So well, I'm not interested in continuing. But if you are, you click yes and then to change. Then so when you have a project that you already have a template you want to copy from, just click on projects and click on select all. But right now it's already clicked, so but then it's not be click on select all and then import. But now we're not interested in all of this, so we'll go back to our work. Then selection method. Selection is performed using the selection button in the member toolbar. So this is our selection method. Although there is no entity to select now, the information is important as you walk through the model. Alright. So select multiple entities. Hold down Control key while you pick them. To left click on entity to select the entity. Selected entities are also highlighted in the structural tree. Alright, then you can select entities directly from the structural tree. But we don't have anything here, so you won't see that. You'll see that as you continue to go. Then drag from left to right to create a rectangular box that will, when you release your mouse button, all entities contained, completely contained within the box will be selected. But when you drag from right to left, and the rectangular box is contains all the entities that are within the boundaries, across the boundaries, they will all be selected. So anyone you touch, just remember to touch. So we've seen all those things there. Then if you right click the selected entities, you'll see the pop out context menu, which allows you to edit and perform other tasks related to that entity. Example, properties, delete, etc. Then pressing escape will deselect all entities. So now zoom and pan. All the instructions are there. To zoom the zoom window, Control plus W to zoom into the area defined by dragging a rectangle. Previous window, Control plus O, that's to zoom to the previous view. Zoom extent, Control plus E to zoom to see the entire entities within your screen. Then the zoom limit to show the limits of the grid. That's Control plus L. Then using our mouse, which I'm using right now, to zoom in, you scroll your mouse, your wheel up. This is zooming in. Then to zoom out, to scroll your wheel down to zoom out. Then to pan, you hold down the middle mouse and you move it around. So that's how you pan. So that. Now modeling axis. The first step to modeling, to build a model, is to define axis. Axis intersections then become the nodes at which members are inserted. Hence, it's critical that axes are created correctly with the correct dimensions, distance, and everything. That is the basics of all your design. If your axis is wrong, that's all the members placed there will be wrong. So the axis toolbar to build, there are three ways of building the model axis. To model an axis, your axis on your design. That's the axis toolbar to build axis individually. That's using, let's go to model now. So this is for your axis, your grid lines. We have the axis toolbar to build axis individually. External reference drawing to import all axes from DXL drawing, that's your AutoCAD drawings. So you can import your axis from your AutoCAD drawing. Then octagonal axis generator to build a system of axes quickly. So that's the octagonal axis generator. So we'll be going through each of these. So axis to grid tool, that's this. Modeling individual axis is simple using the program's dynamic input system DIS. Click on grid. This is the grid. In the modeling tab, there are several intersection methods for axis. So here you have it. There's the different options here. Intersection methods. So this now is called single segments, which allows you to create a straight line axis by clicking on the start and the end point of the axis. So let's try it out here. I have this. This is straight line, no matter where you're going. But then to make it straight without bending, like now you can create angles, but make it straight without angles. You press your, okay, let's just continue. So this is for this. I click to escape also. So we have the multi-segment axis. Enables you to create a single axis with multi-segments of any shape. So that's this one. To create multi-segments of any shape you want to go with. So Let me undo all this. We have the curve axis. So this one you can create curves. Let me demonstrate. Then when you draw it out, you can see. So that's that. So ensure single segment axis is selected. So let's go back to our grid. Single axis selected. Then put the cursor on any of the gray grid intersections. That's this major grid. And the grid intersection snap will show. So that's the grid intersection snap. Then let's click and release to confirm the starting point. So that's our starting point. Then a rubber band will appear and we are cursor to specify the endpoint. Wherever you put it at, you specify the endpoint. So and with that you create an angle, you can see the angle and everything. So getting that. During the rubber band operation, the length L and the local angle will be displayed. In addition, the relative distance x, delta x and delta y will, with respect to the local ECS, will also be shown. Press F2 to enable input of the length of the axis via dynamic input system. So if we have this point now, for us to input the specific length we want to have, click on F2. Let's have this here. No, F2 is clicked and you can see you can specify the length you want. The tab, press tab to circle to this next input angle. So to cycle to the next input angle, press tab. Then if a value is entered in the text box, the related parameter will be locked. You can unlock by pressing escape or pressing the lock icon on the right text box. Let's personalize this. This is what we have now. Let me put 9,000. Okay, 90,000, 9,000. And press enter. It's locked. So no matter how much you extend, it is locked. So you can click on the lock icon. Just press escape. You can press escape and you've unlocked it. So you can extend to any point again. Then if a text box is locked and F2 or enter is pressed, the DIS will be deactivated. However, rubber operation now continues with the locked parameter for ease of use. So according to what it's saying, if you press F2 or enter, you've locked the number in. So the rubber operation now continues with the lock parameter for ease of use. So no matter how you extend, it is locked. You can see a demonstration also on the crystal guide. Then if both of the text boxes are locked, then pressing enter will accept the operation and candidate point will automatically be picked. So let me say use so what that means now is if you have axis line, we picked axis line now. I want to put a figure on it. So I put okay. This is the axis line. F2. Once I go 50,000 and you click enter, it will automatically pick the axis line. Okay, this is too much. So let me shift it to so I edited the line. So now immediately I press enter, it will automatically pick the line for me. The points will be picked. So that's what it means there. Then in either of the text boxes, you can use shortcut notations, length, stroke, angle, or delta x, delta y, without the need to switch it by without the need to switch by tab. What that means is, okay, this line, this is the delta x. You can see the delta x there, the delta y, and then you can see the length and angle. So we can use those notations also. So let's use the example they put there with the shift F2, and they use 6,000 um that was 45 degree. You see how it went. That's it. Then if I'm using delta x and delta y, let me go back here. I'm drawing another line on shift F2. That's 6,000, comma 2,000. So the comma is the notation for delta x and delta y. 6,000 being delta x and 2,000 being delta y. So the point will automatically be picked for me. So this is based on axis, and this is based on the length and angle. Then after specifying the length or and stroke angle, pressing enter or left click will accept the end points. So to control that, try inserting in one second. Okay, we've done that. Okay, let's do the multi-segment axis. And let me delete this. So remember, skip how to highlight from here to here. Delete. Okay, this showing me axis. So now let me use the still on grid lines, the multiple segment axis. So now we have to just use any format of your choice. So let me say from here. So let me just say from here to here. Okay. Let me just here to here. And just form something using the grid lines, or you can use your shift F to 20,000. That's what it takes also. Okay. So enter, then back down. So we just enjoy it. Enjoy it. So we formed the grid lines. I didn't want to stay on that. So using F2 tab, enter define methods. Okay, they should define methods there. Let's go to inserting curved angles, curved axis. I mean, so when you click a point and you click another point on your axis, then you drag it. This is where you want your arc to be, showing negative or towards the positive end of y axis. So if you want it positive, this is it. If you want it negative, so let me say F2 3000, okay, positive. That's it. That's our curved axis. Or you can left click. So that's it. We've created a curved axis now. Let me delete that. So how to install axis from external reference drawing? Please pay attention. This section is for information. A DXF drawing is required if you want to try this out in reference. So you must have a AutoCAD design work. So, but let me use my own work here to just explain it to you. So now we have external reference drawing here. It imports an architectural plan as reference drawing to Protastructure. It's showing you the tips of what it does already. So if I by clicking it now, no member of this inserted and is safe. Okay, so it's reminding me. So now I want to add a DXF file. Take me to my files. So this is a design that's already here. Let me insert it. So now I have it here. So units is in you can change the units if that's not the unit. Use colors. I'm not interested in the opacity. You can change that. The scale is also here. If you want to offset it, it can also be done here. Then This Prota gives you option for 3D, but I'm not interested in that. I just want it to be active to show you how it's done and how it will appear. So now pick the and from here you can see it. This is the drawing. This is the axis. So import the XF. So what I want to import now, if I want to import the column grid wall and everything. So I want to import only the grid lines. I'm not interested in the beam wall and whatever. So I have everything here. The layer is already automatically written on. If I want the column here will show on everything. So this is where it's set. You can edit any of this and then import. I'm not interested in that yet. It's loading. Then close. Okay. So from here now, you can see all the axes on the architectural drawing has been imported automatically. So now I can start working on inserting columns and all that. So this is a very cheap method for you to insert some of the structural members that is already on the architectural drawing from your general arrangement and so whatnot. So this is everything you access on the drawing, so you can follow exactly the architectural design without starting from scratch. So that's what this shows. Let me remove this. Drawing reference. So I make it inactive. Okay. Let's delete that. So I want to remove those. It's still active. What's wrong? Okay. Remove. Okay. Okay, I didn't. Delete. Delete. So that's aspect of Prota that actually gives a more efficient and time usage because it's a shortcut for it to just import everything from your architectural drawing. So let's go through the quick start guide. The add, the active, we already explained everything there. Now let's move to import the XF. This section is for information. A DXF drawing is required if you want to try this out this feature. Three options are available for DXF import into Protastructure, which can be accessed from the quick start menu and so on. So floor plan, 3D physical model, and 3D analytical model. So import DXF if you're importing a drawing which you also wish to use, overlay against your model for condition purpose. Please use external reference drawing options. So we can go through that. Now on importing floor plans. Floor plans can be imported and transformed into 3D elements, a model element. So like I did there, I explained how you can import both the beams, the columns and everything from your AutoCAD drawings, the architectural drawing, straight to Prota. And also you can install the grid and everything. So it explains how it has to be set, the layers and everything on AutoCAD before you can um import it into Protastructure. Yes. So please select the unit file of the Excel file you load. And okay, just a continuation of the explanation, story information, and select the story on which the model is to be generated. That's important because if you click on another story, if you want to select the story, you want to use the DXF you imported on your story 1 and your on story 2. It will appear on story 2 and it will be a different thing on story 1. So it has to be on the story that you want to import those. You have to specify where you want to import the structural members and other things. So you can go through that. Then the orthogonal axis generator. Yes. This is another method, easy method for you to generate your axis. So select all axes separated and press D. Okay, that's delete. Go to the modeling tab and select, this is your modeling tab now, we select the orthogonal axis generator. Refer to the bottom status bar to display text, tell you how to. Um, okay, I just click the points. Pick the intersection on the major grid near the origin, as shown below. Okay, let me cancel this first. It's near the origin, so let's use this as our first point. Then you can see all the details here. Reference by 5000 by 5000 millimeter, axis label A, and step 1. Axis spacing 5000 by 3. You can change that. Axis extension length. So all these are editable. And it's explained here. So just accept all the defaults and press OK. So here it's showing us 5000 by 3. So it's going to be in 3 lines here and then 3 lines up. So the box is going to be 3 and 3. This is 1, 2, 3, 1, 2, 3. So it can be edited though. If you want it in more numbers. And then the span also, it can also be edited as we saw it there, 5000. You can change it to whatever you want to use there. So orthogonal is something like it gives you like the spacing. You've already put the spacing, so it's equal at all points. That's how it goes. So that's what we're going to be using for this beginners class. This is what we'll be using. So now let's resume where we stopped. Both the horizontal and vertical 5 meters. So it was there 5000 by 3. That was 5,000 millimeter. So here is 5,000 5 meter, 5 meter horizontal and vertical. So now we are going to be inserting our structural members. So let's start with the column. Pick RC column icon. This is our column icon. So we are using the default size. The default B1 and B2 is 500 by 250, and E1, E2 is as shown below. So E1 and E2 is 0, 0. E stands for like the eccentricity. So if you want to move it away from the center, you want to move the center away. And then B stands for um breadth, and B2 is the width. So it's shown there. It's just the size of the rectangle that we are using. So we'll see it as we insert. So section manager icon allows you to access other types of columns. This is a section manager icon. This is here. So when you click on it, it's to show you other types of, you can use circular columns, cross, T, and pentagonal. This is not pentagonal, sorry, that's 6 sides. The box, hollow box, and the hollow circular column. Those are different types of column that properties that we have here. So and then the h, the height, and the breadth. Okay, this is our B1. I mean, no, this is our B2. This is our B1. So the breadth and the height. So that's what we call. But basically, this is not the height. Though. The height should be the height of the story. But let's just leave it as it is. Then that's for this. We are going to be doing a normal rectangular. Then insert columns by clicking on the intersection axis. So we are inserting by, this is the axis intersection. Once we put it, you can't insert axis where there's you can't insert columns where there's no, you can't insert any structural member where there's no axis. So there has to be an axis intersection for you to insert a column. The only thing is that maybe you can change the eccentricity to move it away from the center, but you can't insert axis where there's no, and we can't insert structural members where there's no axis. And I will show you all that. So we're inserting columns as guided here. By drag box around the intersection axis. Use the two methods of creating. Okay, so we can insert axis by creating a drag box like this now around the intersection. I've created a drag box. It will insert the columns on each of the intersections, as you can see here. So this is another shortcut. And then you can also insert by just clicking on the points you want the axis to be. So by this now we are done inserting columns. So we inserted 10 numbers of columns. And you can see the dimensions 5,000 and 500 and 250 millimeter. So I close the properties. Always close the member properties when you finish member creation. Yes, that's very important because if you don't close, you click on another place, it will stay inside columns when you're done and it won't change. So you have to close whenever you're done with anything. You have to close. Then click on the wall icon. Modeling wall. Use the default wall thickness 250. The thickness of the wall and the eccentricity is 0. Um, the parameters are explained in the diagram where on the quick start guide, so you can go through that. So E is measured from the center line of the wall to a centroid. So E is the centroid. So like the center line of the wall. So now there is a certain three numbers of wall. This is a reinforced wall. It's not just any wall. So there's brick wall, there's partition walls on Prota, and there's reinforced walls. So this is what we use for things like elevators and reinforcement, retaining walls. Sorry. So this is what is meant by that. We have insert our three number walls. So these are our walls now inserted. Close. Then beam creation. We are going to be inserting our beams also. So we go back to our modeling beam. Um, the properties are there on the quick start guide. You can go through them. You can see the label is here. You can change because normally this label is what will appear when you create your details. So you can put the label you want here, and it will if it's numbers to continue to go in series. So this is the width of beam. This is the height of the beam. So it's 250 by 500 beam that we're inserting. The E is still 0. Then this shows this is two hinge joints, one hinge joint simply supported beam. So you can change to curved beam. We'll be seeing all that. And type of beam, supported beam, wall beam, coupling beam. But this is we are using normal for now. So beam endpoints, beam ends are fixed. So this is fixed joints. So beam ends are fixed by default. You can apply hinges to left or right by clicking successively on this icon, as you saw me do. In the beam properties, use the default values 250 and h the height 500. Then create a beam, click on the intersection of axis for the start and the end of the beam. Notice that you can continue to create the beams from the previous continuously. Or previous beam continuously. So let's see what that's about. So we are following their guide here. So according to what is on, we can put our beam singularly. If you extend it will break automatically. That is how it's done here. If you extend it to break automatically, you can still use the method we used the other previous time for the columns, like clicking. So that's another method. You can press right click to end. Sorry, this is multiple now created. But there's an error here. Okay, it broke at the point of the wall because beam and the walls can't cross each other. So it's same thing here. Well, I can't do that here because okay, yeah, that is. So I'm following the guide on this quick start guide. So now place my last beam. Like click and close. So now you can see our structural tree is growing. the structural element we place. With each structural element, it continues to grow. So check the folder names in the structural tree to ensure that you have inserted the total number of 18. So from here you count, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18. So we've inserted 18 beams. You can see the following numbers in series. So I didn't need to count. So click on the axis. Okay, to insert our curve beam now, for example, and click on axis A3. That's this is our A3. This is our B4. So we are clicking start and end there. So back to modeling beam. So click on our curve beam. Now we use this as our start point, end point. That's it here. So now we'll insert our figures. Minus, don't forget that negative. If not, it will go the other way where you're not interested in. So the negative is there. Minus 1500. So that's our curve beam. So we just define the radius. So what we did was to define the radius. That's going to be minus 1500. And then we'll press enter. We created our 19 beams. So beam creation using dynamic snap points. Let me explain what that means. When you insert beams now, let me use this point. When you insert beams, you have different points here. You can see the snap points 0.25 length. That's on the beam we've created here now. 0.33 length, half 0.5, 0.67, 0.75. So each snap point represents a point on this beam. So click beam icon and place the cursor on the edge of primary beam. Now when you want to place a beam on another beam. So notice this that snap point on 0.25L, 0.33L, 0.5L, 0.67L, and 0.75L will be shown when the cursor is placed on the beam. Click on 0.67L, so this is 0.67. That's the start point of the secondary beam. Place the cursor on the destination beam. Let's put it on this beam now. This is another 0.67. You can see that it's aligned. The same thing goes on all the beams. You can see the snap points on the beam and the perpendicular also. The perpendicular here is 0.67 on the both sides. So if I want to, I can select now. I've created my beam resting on other beams. So this is the secondary beam. These are the primary beams. If I'm understood. And pressing left to right the cursor is at any of the snap points will allow input the exact distance from the start of the beam. So if you press enter to allow input from the exact distance from the start of the beam. Then press the control key while the cursor is placed on the primary beam will expose distance of increment. Oh, sorry. Okay. We expose pressing Ctrl key while the cursor is placed on the primary beam will expose distance of increment 100 mm. Left click to select the distance. So if I'm holding control now, let's do now. So showing me the distance of increments. So I can place from the end of the distance. Let me say 250 now. Showing me the points as it goes. So I can when I reach a point where I like I'm interested in, let me say this, I wanted it at 2200. Click on this point and it creates. So let's close the beam as the latest. We're not going to be using this. So now, so I draw the position of columns and beams. Let's do that. So now we are changing eccentricity of the column and the beam by simply selecting it and then pressing keyboard arrow to move it in the direction I want. So now I've clicked on this column and I want to move it in. You can see it's moving as I click on my right arrow, click on the left arrow, moves it out, click on the right arrow, moves it in. So I want to select one. Perfect. That's it there. That's another tip and shortcut that was created here. Exactly. Then select column. Okay, that's what we just did. That was JC1. I'll press the arrow key towards the right to move it inward. The step by which the member is moved can be set in building setouts, setting center view. Okay, you can see all that. View and save. So the member is electricity. You can edit the steps. Okay, let me show you that. Settings. So on the view and save setting, you can see um general. This is general. Member section eccentricity step. So we can edit the steps by which each move is currently by default on 25 millimeter. So that's what's set and I like it that way. So okay. Now slab creation. Click on the slab icon, modeling, the slab icon. So now click on the type box. This is the type box. You can see the different types of slabs. But based on their support, this is supported on all four sides, supported on three sides, three sides. The cantilever slab, supported on two sides, on the left and right. So you can see all the types here. So that's for the types. The label, you can edit the label. The height by default is 120 millimeter, and the cover, concrete cover can be edited by default is 20 millimeter. Then the angle can be shown here. Label icons activates the slab label plus control the position of the slab label. Insertion method. Insertion method. That's this. You can insert by through the axis region. As if you want your insertion to be based on axis region, the beam region, within the beam region, pick axis points, pick points, pick closed slab edge. So we're using the beam region because we've created our beams. So in some situations where the beams are not there and I want to insert in the axis region, like maybe a cantilever slab now, and it's supported on one side, and we want to put it in the beam in the axis region. So we use this. So as we continue to work with Prota, you continue to see all those things. Then select slab type as one. So we use slab type one for ease to creating the model. We will initially leave slab type as one for all slabs. Once they have been created and when we are ready to design the slab, there's a function automatically set to correct type for each slab covered later. So each slab thickness, the height is we are using 200 now. So 200 and our cover is 30 according to the quick start guide. So now we are going to be placing our load. So we'll go to loads. From the loads, we are looking at what we're given here. Our service dead load is 1.2. So 1.2. And our impulse load according to the quick start guide is 3. 3 not 30. So you can add other things depending on the region, roof load, snow load, rain load, but we are not interested in all of that now. So the self weight is already automatically calculated here. Then you can insert more dead load because if you see here we have different values for different dead loads. experiences. Let me say for flat roof, room, terrace, balcony, and everything. If I click on any of this now, to give me the dead loads that's already automatically installed in the software. But this is what we're using now. So going back, we've been setting our loads, our slabs. So this will be our first slab. As you can see, it's there. And showing is already automatically calculated as a two-way slab. So we're inserting 7 more slabs. So there we have it. Our slab creation is all complete. So now polyline slab and column edge. So what that means, this section is optional. It's not part of the final module. The slab edge line can be used to create irregular slab lines. So click polyline slab column edge. Let's see. This is polyline slab. A column edge starts from here. So click continuously to define the edge of the cantilever. So using this point. So I'm going from here now to this point. Oh, okay. Very small slab to show example. This is a polyline slab. Finish. Now click on slab icon. So the type one is still selected. So in insertion we'll be using okay, beam region is selected. So click anywhere within the slab edge. So this is here. Make sure that it's showing before you click on OK, before you click on any points, you have to make sure that it's showing the line to show you the path where it's going to be. Now click on it. And our slab will appear. So that will be a cantilever slab. Oh, yes. That is not. I think it's attached to. Component. Everything is set. Let me redo this and see. The polyline. Okay, I started from the edge, not from the center. That was my mistake. So I'm clicking on the slab icon. Place it in. And that's it. So here we have our cantilever slab. So now you can see the final thing here. Okay. So notes for regular cantilever slab, it is recommended to use type 12. So type 12 on the slab, you see it is cantilever instead of the slab edge line. Okay, let me confirm. I think it changed some of the things from here. So our own cantilever slab is type 6. Okay, this is type 12. Yes, they are correct. Slab properties instead of the slab edge line. So tip, the slab column edge line also includes circle, arc, and rectangle, and the ability to convert to a column or slab hole or slab drop after drawing a closed shape line. Select it, right-click it, convert to column or slab hole drop. So that's another feature that we can use. We're not using it here. So for views creation now, Basically, this has been made simple. You don't need to call the way to views, but yeah, this is where you can create everything. Or it's already all here for us to use. So you can. This is the plan view. I can make the 3D physical mode. So it's already online. Here's our plan view. This is the 3D. The reason I'm holding the right click to hover over to um move around. So this is everything. Right now, this is clicked on. The active um structure element is this. That's why it's showing red. It's active from here. You can see it. So the indicator show you which element is active. So if I press escape now, it shows us normal. So you can see everything now. Slab, our column. And you can also navigate from this glue box. So for that, we've created our 3D. You can create the more views. We have the 3D rebound model analytical mode, but these are after we've done our analysis. So inserting stories and defining building parameters. The final model will be a 4-story building. So we will now insert the other floors. So inside this video, we go to floors, we go to our building setup, then story drop. This is stories. This drop down. Then insert stories. Insert stories. So now we're having a total of 4 stories. So we'll press click on 4. That's it. 4. Okay. So it won't be undone. If you create this now, you have to delete. If you want to remove the stories now, you have to delete the whole members on that story. So once you've done this, it can be undone. But you can change it, yeah. It's not like it's permanent. So that's what this is saying. Clicking OK, we've created 4 stories. So now we have this story 4, making story 3 active, story 3, story 2, story 1. These are have all our structural elements. So this automatically inserts story 2, 3, 4. So now to edit the story from the same story drop down menu. That's yeah. You will see define. Okay, let's see. Okay, for story drop down menu to edit story. So this is our menu. So edit story. Our story 1, 2, 3, 4. So now we'll define selected stories as similar. So we are selecting all the stories. Okay, now so we are doing only story 1, 2, and 3. And click define story. So 1, 2, and 3. Define selected story as similar. Okay. So now we are also editing the label of the story. These are our ground floor, so change to G. And this we are changing it to R. That's our roof floor. So now if we go back, we'll see that the story, the members have been generated from story 1 to 2 and 3. You can see everything here. So now we have done that, click OK. We've finished everything here. You can see it's been generated on story 2 and 3 in this point. So now story 2, story 3. All the members have been generated. So now we'll pick generate story from the same drop down menu. So now we're picking story 1 as our source story and target story will be story 2. Story 4, sorry. And click OK. All the members are clicked. So these are options in case you want to remove any of the members or select them not by yourself. Well, everything is selected automatically. So click OK. So now, if you go back to our tree, you will see that story 4 has been generated automatically, identical to story 1 and the other stories. So now we'll be adding a new slab to cover this lift core on story 4. So this is the plan view. So we'll create a new slab. So right click anywhere on the plan view to expose the context menu. So we'll select member table. So we'll click on slab table. It allows you to view and change parameters of the slab in a group. So this is our slab table. Okay, before I do this, let me close this. Let me create the slab here. So remember 200, 200. Our slab cover is 30 and equals load 1.2. Okay, let me close this. There's another way to do this easier. So I'll right click properties. So I have the properties of the previous slab and I'll just click on this one. And automatically to follow the label in series. And all the slab properties will be here. So I close this now. And escape. Right click to deselect all members. So now right click anywhere to show you this. So members table, slab table. So this is opportunity. This give you an area to change the parameters of the slabs in groups. So we can change anything from here. So click on the header Q. This is Q. So that left and the entire column will be selected. Then click clockwise edit. Okay, click that left and the entire column will be selected. Clockwise edit icon. That's this clockwise edit here. So we'll click on that. Enter 1.5 is there. You can see the other dead loads there. So enter 0.75, 0.75 and press enter. Oh, okay. So all slabs live loads values will be changed to 0.75. You can see it's all changed. So now we'll close that table and we have what we computed. So if you want to confirm now, you can click on this properties loads. See, import loads already changed to 0.75. So that's what about that. Wall loads library inserting brick wall loads. So this is let me say the partition walls. So you can set up predefined all loads and then apply them using drop down list when adding the wall loads. So go to building setouts and partition walls, load libraries. See what I mean? So building setup, load libraries, partition walls. So you can set there. So by default, all types are automatically set up, but you can add any new user defined wall type. So you can use anyone you want to. So I'll click on cancel to exit. Then when I insert brick wall loads on the game in story 1, so let's go to make story 1 active. So now enter a perimeter beam. Select the perimeter beam and click edit for loads. Let me use this beam now. This is the perimeter beam. So edit for loads in the beam. So this is what appears. So partial walls can be entered by checking define wall loads, wall length manually. Enter wall length, enter reference X for position to start. Okay, that's for inserting. So alternative, you can select the beam, right click and edit wall load. Try what I did here. Then choose 200 brick wall Singapore. Oh, okay, enter. Okay, let me close this first. Okay, you can do that here. 200 brick wall Singapore. So this is here. Then choose 200 brick wall Singapore. Enter wall height as 3 meter. So the wall height is going to be 3, 3 meter. We'll click on OK. You can edit the wall thickness. The unit weight is automatically giving it to you there. You can also edit it. The dead load is given to you there. Automatically calculated by Prota. So click on any other box for diagram to reflect to refresh. So I'll click on OK. So now let's examine this in 3D. You can see that we edited one, it's affected the remaining. So that's why it says because we inserted stories on this, but it won't affect story 4 because we generated story. So it wasn't just inserted, so it's not identical. Remember what he said about it in the previous section. So now we're going to be copying the wall load. Let's go back to the plan. We apply the wall load to remaining things. So we'll copy wall, then we'll select all the parameters by holding down Control. While selecting the beams, you can also a drag box select the parameters. It doesn't matter if the columns are selected. So we'll press Ctrl and then select all the perimeter beams. You can see that it's automatically the walls are already there. You select them. Since it doesn't matter if the columns are also selected. Let me start this over. So copy wall load. Now to select multiple. So now right click and press paste. Paste copy bin one loads. Okay, mhm. I skipped this bin. So I'll go back to this. So right click. All of them are selected though. So I'll copy, use, and paste. So I'll copy the bin one load from this. Copy all, just copy bin one load. So that is escape. So that's everything that we inspect it on our 3D view. You can see all the perimeter walls have been added to it. So the model is now complete and we're ready to run analysis. So we finished our model. Congratulations, guys. So now running analysis. We'll go to analysis. Then click on building analysis. Building analysis. Then this is pre-analysis part. Okay. So the pre-analysis settings is where main assumptions of the analysis can be defined. Project parameters. Review or modify the analysis parameters such as the design code and notional horizontal loads. Let me open it so we can see that. This is design codes. Okay. Then load combination. Generate, add or modify any load case or load combination sets. I mean, so you don't have any combination yet, we'll go back to that. Then read and story loads automatically generate win loads, review and impute any lateral load. So that's this. It's already inserted some automatically generates lateral loads such as the notional horizontal loads will only be calculated and shown after the analysis. So edit materials, review, add or change the concrete steel and the steel material and anything. So whatever materials we use on site, you can edit them to whatever we use on the analysis. This is where we'll be editing everything. The materials that we choose to use in our design. So we'll be getting into all this right now. So we'll start with materials now. I will now define the materials for the project via building analysis pre-analysis dialog. So edit materials. This is the first material, the foundation floor and everything. So now the materials and reinforcement steel grades are shown for all member types. The first materials is used for superstructure floors. A separate foundation floor category is automatically created for the foundation members only. That's this. You can see here. Then if there's a different material for a particular story, a separate material setting can be added by picking the plus icon. So if there's an additional material for a different story, it can be done that by picking the icon. You can see story 1 is already highlighted here. You can edit that. Steel reinforcement grades and diameters are also defined here. So pick column concrete grade. This is the grade. Oh, sorry. This is the concrete grade here. And we are using C30 stroke 37. Apply to all members in the story and click OK. C30 is already selected. Material name. To apply to all members, this is where we click on. But here now we have concrete grade of C30 even or 35. Oh, in this new Prota, you can only select one particular grade. So let's stick to C30 and apply to all members. So running C30, C30. So pick steel grade and ensure that grade 500. The 500 is what we use. So you can apply to all members also. Click OK. So now pick diameter and select the desired rebar diameter to be used in the member's design. So we'll click on the rebar diameter and let's use 12, 16, 20 y20, y25 and y30. Let's remove all other. This is what we'll be using. Then apply to all rebars. Okay. Well, normally we have to edit this because the links will not be the same. The links will only be let me say y10. Depends on what you use in your region. Let's say y10. don't have rib slabs. It slab would be like say white. Let's use white for our slabs. Then beam and columns can use the remain the same thing. Then let's use white over and white 16 for our wall. Okay. So now we are done with that. Okay. So we return to the media analysis dialog. Now for the load combination, we will now auto generate the load cases and load combinations. So we'll click on load conditions combinations and then apply p data analysis. Let me follow what they have here. Select this. So this is the load combination editor. You can add new load cases manually and then load combinations. However, it is easiest just to use the load generator automatically. So click on the load generator. Use the option as shown below and click OK. So according to what was picked, these two were picked as it says here default. This was also picked. Then for a template, okay, this and this were also picked. So direct dependent pattern loading. Oh, that's this. What else was deleted? Go to horizontal loads. National loading is already selected, so we don't need to do anything here. If you're using the same default with me. So now you can choose which combinations is used for concrete and steel design separately. If use cracked sections is checked, section stiffness factors will be applied to for the load cases. All the load cases and combination will automatically be generated as shown below. So by clicking OK, it says so it's automatically generated our load cases. So it doesn't seem the same with what they have there, but this is what is generated. Then we click on OK. Now building analysis model options. So go to the model options, model and material and section, cheapness factor, and review the assumptions as shown below. So this is what we have there. These are the assumptions. Note: the stiffness table will only be applied for load cases with used crack sections. So each seismic code has its own set default values. The editor code will change turn orange to inform users that if an entered value is different than the default. So building analysis must be repeated each time the effective stiffness factors are changed. To prevent large torsional forces in primary beams due to secondary beams, the global torsional stiffness factor is by default set to 0.10, that's 10% in the stiffness settings. You can edit that. Stiffnesses of individual members can be changed by selecting a member. Right click, edit section stroke material and properties tab. So we are not changing anything in this. You see user defined support. So now running analysis, let's go to the main analysis. Go to the analysis tab before running the analysis. It's always recommended that we check the validity of the model. So we have to check the validity of the model. So checking the validity of the model, we'll click on the building model check. Building model check. All the parameters are picked already. I'll pick all storage is already picked there. So we'll start and wait for it to load. It will check for errors in balance or anything in the model, in the general model. So it's not analyzing anything, it's just checking our model to see for obvious errors. And according to it, you can confirm that there are no errors. Number of errors 0. So we'll close this. Then The video model should pick up the most obvious warnings errors. Okay, you should review any warnings. Click load log to editor to open the list of warnings. We don't need that. We didn't have any warnings, so click on close. The video analysis cannot be performed. So we click on video analysis. Area values analysis can be done to obtain the natural frequencies and mode shapes of the structure. The batch design options dialog will appear. It allows you to perform the design of column stroke wall and beams automatically after the analysis. We suggest that this should only be done if you are confident that the result is correct. So check wall reinforcement design. That's this. And beam reinforcement design. That's this. Peak building analysis to analyze the model. We've not. So we don't have any design yet. So we are not really selecting anything. So we just design for this. The analysis will also check for instability and large deformations. So we're running the analysis now. We'll check for instability and large deformations, and there will be warning signs if any are found. Analysis summary report will appear at the end of the analysis, summarizing the important results. Okay, what's going on? The video analysis is being carried out. Uh, so we'll wait for the analysis to be done. Yes, analyzing and designing the reinforcement bars for each um, structural members. So it's calculating the design force and everything. So wait for this to be done. Oh, still waiting. So video analysis completed successfully. So close this. Come back to Prota. Now the analysis is done. Okay, it's all done. So let's close this. You can see now we have our analytical mode showing the analysis. You can see that there are no reds, no obvious deformations in anything. So our structure is valid. It's that way. Really. So let's go to actual load. Let me go back to that video analysis. So for actual load comparison report, an important check on the validity of the analysis is the actual load comparison report. This report sums all of the dead and live load applied to each story and displays the actual axial forces in the columns and shear walls. These values need to agree with each other with a tolerance limit of 5%. If they do not, the reason for the discrepancy should be investigated. So select um, actual load comparison reports in the analysis tab. So we're waiting. So now the reports are loaded. This is the actual load report. As you can see, the tolerance level is not above 5%. They agree with each other. Awesome. The values agree with each other. So we don't have any issue here. So table one is total loads based on slab. It is sum of dead and live loads of all members with the slab load not yet decomposed or calculated on the beam. You can take this as the input weight of the structure. The table 2 live loads, the compositions of beams, take into account the decomposition of slab loads onto the beams based on either yield line or FE, that's fixed end decomposition. The beam load now includes the slab loads and hence zero values are shown under the slab column as is shown here. Then table 3 building analysis columns and wall axial loads sums up the actual column wall axial loads after building analysis. Firstly, check table 1 and total values which are similar to one of table 2. So if the table 1 total values are similar to table 2, this ensures that all slab loads are accurately captured by beams. And that is no slab loads are lost. Then verify table 2 total values are similar to table 3. Please verify that this ensures that all the superstructured weight is completely captured by the columns and walls down to the foundation. So now you can save this in PDF, save it to your system for as part of your calculations. So we'll close this. Now analysis model and result display. The model analysis result display enables you to review the results of the analysis graphically. By default, a view will automatically open once the building analysis is successfully dialogued. So this was the view that was opened. That I showed on screen. In your, if it's not open, you go to the post analysis tab and click display analytical model. So close the building analysis model dialog. The new analytical model tab is set to appear together with analytical model view. So this is the you can go to the quick start guide to get accustomed to the interface. So let's do a small exercise. So in the general tab, click on the filters command, which is now active. So the filter option will appear on the left hand side of the view. There is an option to filter the play by stories. Okay, this is the filter already here. So find command allows you to find a particular node. That is frame or shell number. Connectivity issues lists all the frames with unsupported nodes and highlights it when selected. This is the connectivity issues. No connectivity issues detected. Click the member tab. Members. This is where you can show node label, rigid diaphragms, element label, and beam loads. So let's click on frame loads. You can see the loads on each frames. So then displacements can. So I'm skipping all those parts. You can go through them on this quick start guide. They're also important though. But there's something you can do on our own to see all those things. So just follow the quick start guide. So now we'll be going through to the column and wall design. So this is I went to design. This is design. So column now. Open this. You can see they all pass. So with Prota, we can open any of the this is ground for column 1 and see the design. So we can interact with it physically. This is the arrangement of the column The column reinforcement. This is the properties we used. The arrangement, the load combinations that we use. So the links, share, design, slenderness, the settings. So everything is here. You can interact with it. Interactive design. You can see because the designs everything about it. So you can interact with it in details here. Okay. Parameter set. So if you're not design, you can choose column design batch mode. Like okay, let me say if this was not designed now, let me say this last one wasn't designed. Double click on it to open it. So interactive design. This is okay. That's for single, or we can just go to column design batch mode and design it all the columns at one go. So now go to reports. Now click on choose design reports. And the columns to be included in the report are marked by a tick in the print column. So if the column is in text here, it won't appear in the report. So mark all. So click include column show call in the report. So draw the column section details. Check include. Okay, we done that. You can also give the report a title. So you can put column reports. Let me just put column and then click on OK. So wait for it to generate the report. So all reports can be exported as PDF, MS Word, image, or web page HTML formats. So these are the options on how to save them. PDF, you save it to as PDF, so choose the file you want it to be saved. So exit. This report will automatically be saved and made available for compilation in Report Manager. That's drawing a report here. We'll get to that. So now, the interactive column designs allows you to examine, alter individual column designs in more details. So you can go into that in the quick start guide. So I've closed that. Now we'll go to the beam design. Story beams. Since you have selected to run beam design, reinforcement design as part of the video analysis, all the beams are already designed as indicated by green ticks. So you can see the green ticks, all the beams are designed and they all check out. If it shows exams there's something wrong with the design and then it failed or something, or it wasn't designed, so we have to go through and check what the problem is. So if they are not designed, you can choose beam design batch mode to design all the beams at one go. So now choose remove print marks to exclude all beams in the report. So that's this remove print marks. Then check the checkbox under the print to show the first row beams only. And that is A. So let me check this now. And choose design report. Design report. So all checked. So click OK. Within design reports is an enriched text format. Choose the preferred report option to include the various forces diaphragm. So you can see the reports of that particular beam. I will select. So if all the selected will show the same information on each of the beams in every story. So now with that, we'll close this. This report will automatically be saved also. And we can also access it in the compilation report manager. Now double click on any of the beam and to see like, so this is more interactive. You can still add, see, And you can see manually add um more reinforcements if it fails or something. So any figures in red indicates a failure to meet the design criteria and should be investigated. So more details on each of this is shown. These are the arrangement of the reinforcement bars is shown here. You can see how it's arranged here, the connection and everything. These are the loads, deflection check. You know the rules of everything. It must be less than 4.16, 41.69. So it's all there. You can see the reverse, the deflection check, the extra requires reinforcement data, everything is there. So areas, all the area requirements, the reinforcement data, the required areas, extra areas, reverse, everything is shown there. Now load diaphragms and deflections. So click on the diaphragm button to see the. So let's do that. The diagram button. So you can see the diagram. Display details values. So you can see the values there at each point. Distance, the share force and everything. Load combination. So we can go through that on our phone. Really quick start guide. So now visualization tools and reports. Let's close this. Horizontal scale. Increase the horizontal scale. Okay. That's it on the film. So now for slab analysis design. For slab For beam slab models, slab reinforcements can be obtained by inserting slab strips in the x direction horizontal plane and y direction vertical plane. This process uses moment coefficient method for the tables in PS 8110. This is independent of the general building analysis and can therefore be carried out before or after the general building analysis. To use the moment coefficient method, it is important to set all the slab types correctly in accordance with the tables in PS 8110. This can be done automatically in a batch mode by right-clicking on the slab icon in the structural tree and choose set slab types automatically. So let's see what that is. So in the batch mode, by clicking on the slab icon in the structural tree. So where the slab, this is the slab icon, and you see set slab types automatically. Apply to all stories in the slab. So click on OK. So all the slab types are already automatically generated. The slab strip's properties will be displayed when we click on the slab strip. So let's go to story 1. Let's start with story 1. Okay, this is story 1 already. So now modeling. Modeling. So now we insert slab strip. The properties are displayed. The type analytical strip is used for design based on the code method. FE strip is used for design based on FE flow analytical method. Then the manual strip is also there. When drawing the strips, it is essential that the correct at start and at end conditions are specified. The three options being so now this option is it shows this is a code slab according to them. The slab strips or ends is inside of the slab. So it's either let me see, I'm drawing from here to here or outside. So let me say at start now I'm starting from here. At end maybe I'm ending inside the slab. So the start and the end is inside the slab. Then this bulb means that you're starting from outside the slab and you're ending at end also. If I put a bulb, I'm ending outside the slab. For this cantilever now, this slab strip starts or ends beyond the cantilever slab. If you guys understand. either it starts or ends beyond the cantilever slab. So let me say it starts now. I'm starting at this point, or it ends at the cantilever slab. If that is understood. So now we'll start our slab shifts. So setting our direction at X, we'll start from placing our is on above analytical strip. We placed our start point in the middle of this axis. Then holding control, make it straight. So you can see now we have a straight. It's not as many sudden there to be following the course of wherever it goes. But now it's straight. So start and end at this point. Do the same for this axis. You can see the reinforcements already there. And you can see this the spanning of the slabs, the two-way spanning slab. So the reinforcements are shown on the x-axis. And now we'll do the same for the y-axis also. So set our directions to y, starting from number 1 again, Bob. So we are doing the same thing basically, starting from here. Now for this now, you see that there's a cantilever here. So it's starting from a cantilever slab. I remember what we said about starter and the strip start on or ends on or beyond the cantilever slab. So it's starting beyond the cantilever slab. So we put our start here and then it's one responding slab. So we add this to this. So you can see now the reinforcements are set. After it is set to return into the slab. So essentially you understand what this is. So now we are done with our slab strips. So we can now recheck the strips as a batch and create a slab analysis and report. So to go to design tab and close this now. And then show slab analysis and design. Check design. So click on design. So the report shows. So we review the report and then exit. So this is the report of the slab. For each slab we've done. So now for design status, it will show all the parts of our drawings that have been designed. So the design status can be displayed graphically or in plan or in 3D window. Click on the 3D window to make it active. So we're on the 3D window now, it's active. And then go to review tab, review, then pick design status. This has made it easier for us. But design status, yes. This is it. Now you can see all the parts of our design have been. Oh, there's an error. I'll go back to my designs. Some of the views are showing that they're not designed. Okay, so now I've sorted that out. All the structural members are designed, as you can see here. So, what's next? Quantity extraction tables. The concrete and formwork quantity reports can be produced. Protastructure has given you that. Go to drawings reports, go into report, and then pick on quantity extraction tables. Concrete homework. But let's leave homework for this first. Let's just leave it as concrete. Then calculate. So click on reports. So this is a detailed report for the concrete quantity takeoff. You can see. So the volume is calculated. Now close project reference close. So project reference. The project reference preference dialog allows you to enter the details of the project model. Click on settings. Okay, so let's go to that. Center expand project preference. Okay, alright. So you can see the header, title, statistics, notes. So anything you want to change on your project preference, the header of a project can controlled, calculated by, controlled by, drawn by, presented. It will all be there in your reports, in your designs, in your details. So it should be printed out with this, the header and everything. So key in the various information in the header tabs as desired. So whatever you want to put in there. So click OK. Then you can put whatever details you want to put in there. The report manager. The report manager is the central report manager where all analysis and design reports can be accessed and managed. So where is this? Let's go to drawing and reports and then choose report manager. It's loading. Okay. Then we have our report pre-analysis check, themes load, collaboration dead load was, analysis reports. We have everything here. So report sets, reports repository and notifications. So we have everything here. So we generated reports for all those things, so you can see the reports here. You can go through the report set name, add all available. So just according to what's on the quick start guide. So to compile all the results, new report from file, create a file. Okay, that's if you want to add a report. Then to add, select new to give new reports and give the new report set a new name. Select all available reports in the report window. Include only reports that are available and generate the report repository. So all this you can go through the steps there to combine that. And then that is that about this design generated and reports. So now I'm going to be adding some things that are not on the quick start guide. I'll be showing you how to put planes and foundations on this design. So I'll be using the design to insert part footings on the foundation. So I'll be taking you on that and then planes, how to insert planes. So this is going to be the last part of this. So I'll start editing it. So we'll be doing the planes first. So I pick the octagonal and then pick this edge of the grid. Yeah, I'll change this to 2. Change this also to 2. Okay. Now we have this. So now I'll first place my column. 1, 2, 3. Just here also. 1, 2, 3. And place here also 1, 2. Okay. Then let me start pin. games around it. So I'm not changing it, I'm just showing an illustration. So I have that. Then I put slabs. Okay, let me change this at least. Use the property of this. Realistic, I'm sorry. So slab properties. Just insert some. So now that. So Zoom is a way of making your structural members slanted, not straight. So now we put in plain definitions. So let's check this out here. Um, this is set to bin region. Same way you insert your slabs. These are the levels you are slanting your members. So let me pick this now. So my phone. Yeah. Point one should be, let me put at 0. Then this let me put at 2000. Some put this at 2000. So I'll pick the points now. So I'll update this. By this now, I'm going to clicking this and picking the points. Let me say this is 5.1, making this 5.2, making this 5.3. Okay, I should have put this. This is supposed to be minus 2000 minus. So now I update this. And so it's close. So we check the 3D. Now we can look at this here. It's not reflecting it. So let me, from here now you can see planes. So I've inserted it, but it's not showing here. So I have to move members to plane. All members contain the area. Okay, yes. So now go to your 3D, you see, so created. This is what it means. Now let me do the same for this other side. I'll add plane definitions. Okay, then make this minus 2000. Minus 2000. So now I'll pick my points again. So say this is 0.10. Also point object this. Move minus the direction. Yes. Now we'll go to 3D, you see, repeated this. So now, if you notice the columns at this point also move, but we can change that. So click on, let's control, click on these columns, and then properties. So now we'll see all the properties of this. Click on this and click 0. Click on 0 and press enter. So we can close this and you see that the columns at this point here, they are back to their normal positions. Let's see that. So, oh, they're all back to their positions. Let me do the same for this also. Okay, this never moved. They are already in their original positions. So is this one's. But now we can reduce the height of this. Now, look at properties. And then on this here, on top. So, shift and drop that signal from this to minus 2000. Press enter. You see the all change. Then close. You see, oh, the issue here is, uh, because of our previous edits, it automatically generates our members. So whatever we do to the first floor, it affects the following floor. So we have to go back. So because of that, let me just leave it as this here. As you can see it here. So I'll leave it as this. Then maybe if I eliminate these floors now, it will also do the same. So I'll leave it like this. So this is plain. At least we get the concept of it all. So this is what plain definition means. Slanting on members. So you can see how slant this is. This is well defined. So that's for plain. Aspect of now in foundations we say spirit. See the stuff. I've not done the analysis again, so I have to go back to the two run analysis. So video analysis, global analysis. Let me run the video model check first. Number of errors also. Video analysis. So now the analysis has been successfully done. I can close this. Okay, bring it again. I don't know that. Okay, show me. There's some AI showed. So let me fix that quickly. So now I fixed all the field beams and columns. So that's a minor error. So what I'll be doing now, I'm going down to the story zero on my plan view. Okay. So now I can start inserting the file footing. So click on the column base, right click on it. Then you see the options here, insert path footing. So click on it. So your path footing has already been designed here. And geometry, pedestal, analysis, everything is here. If you want to shift it a little bit, the eccentricity is also here. This is the column property here. And you can see the 3D view of your path footing. And see, showing the reinforcement and the basket and everything. So this is going to be the path footing. And it's now successful. I see the properties here. So click on OK. Just so now another thing, when you have okay, you can also design footings as one. Let me show what I mean. Like if I want to use the same it might, sorry, hold your control, select multiple. You can design multiple, but the disadvantage of this is that some of this um the columns might be carrying lesser loads than the others. And designing this as one will increase the size of the part putting in all of them. So I don't advise it normally, but since we're just illustrating something here, um, what's wrong with this one? Field. So for this one, let me see if I increase the depth, it increase. Oh wait, let me try. Okay, let me increase the depth. So these are all the parameters to cover everything is here. So for those that want to increase the depth and it passed. So clicking on OK. I'm not going into detail because I'm supposed to go and check back what's made it to fail. Well, I don't want to do that right now. So because this is just a beginner's class. So with that now, we've designed the power buttons for all the columns. And you can also check this, but go back to our 3D view to see what we've done here. So you can see our building standing gallantly. Then we can also do the same for this place here. Let me go back to my plan and run the same thing here. So just select all my columns. So I click insert part footings. So we're going to be designing all of them. It's taking this time. All passed. As if you want to check in details, you can see the details here. The depth 400, it has calculated the depth, the cover and everything. But this cover now, you can edit it for yourself to know the preference you want. So these are all edited. You can check the 3D view. Confirm, see the size of the basket, the column, and everything. And click OK. So you're happy with this. You can see this is larger because most of the load is on this. Let me show something. Okay. Well, this is our footings. So put our hard footings. Um. So yeah, basically we're done with our design. This is our structures. This is what we've created, and we finished our design. So thank you for joining us in our beginners tutorial. I'm grateful for being here. And I want to thank Gem Ametis for giving me the opportunity also to be part of this growth. So this will be the end of the lecture.